Points A, B, C lie in a straight line inclined at an angle 30 degrees to the horizontal. A box of mass 5 kilograms is pushed from A to C by a force parallel to the plane of magnitude 48 newtons. The box is at rest at A and it takes 1.2 seconds to reach B. The slope is smooth between A and B. Between B and C, the slope is rough with a coefficient of friction of 0.8. The box comes to rest at C. Determine the distance AC. Now, in all mechanics questions, you really should draw a diagram to be order to help you be successful. So, drawing a plane at 30 degrees with a box on it of 5 kilograms. Putting on the points A, B, and C, we know from A to B it is smooth, and then from B to C it is rough. Now the forces acting on the box will be 5g newtons acting downwards. A normal reaction are newtons, and we got a force parallel to the slope 48 newtons. Now these are split into components. This angle here will be 30 degrees. But this component here, this one here, which we're interested in, which will be 5g sine 30 degrees. Now the initial velocity is 0 meters per second. From A to B, now what we're going to do is calculate what the acceleration will be using Newton's second law. So resolving horizontally, we've got 48 newtons acting up the slope. Acting against that, we've got this one here, 5g sine 30. Notice it will be opposite the 30 degree angle. And that's going to be equal to 5a. And therefore, AB will be 48 minus 5g sine 30 over 5, which will give an acceleration of 4.7 meters per second squared. We'll put that on the diagram. And now what we're going to do, we know it takes 1.2 seconds to get to B with an acceleration of 4.7 meters per second with an initial velocity of 0. So SAB will be UT plus a half AT squared. So it'll be 0 times 1.2 seconds plus a half times 4.7 times 1.2 squared, which will give me 3.384 meters. So we now know the distance from A to B is 3.384. The velocity when it gets to B will be U plus AT. So it'll be 0 plus 4.7 times 1.2, which will give me 5.64 meters per second. So this will now become the initial velocity in the next part of the journey, which, bear in mind, the slope is now rough. So from B to C, so using our diagram, draw a second diagram. Okay, so we have one extra force acting now down the slope, the frictional force, which is mu r. And the initial velocity is 5.64 meters per second. And we want to know, it'll get to see when the velocity is 0. So the frictional force will be F is equal to mu r. And that's going to be 0.8 times, now this component here, this minus this component here must be equal to 0. So these must be equal, so this component here is 5g cos 30. And therefore, resolving horizontally, we're going to have 48 acting up the slope. Down the slope, we're going to have this little bit of weight here, which is 5g sine 30, minus mu, which is 0.8, times r, which is 5g cos 30. And that's going to be equal to 5a. A will be all of this divided by 5, which will give an answer AC being minus 2.089 meters per second. We'll place that on the diagram. So we can now calculate the distance using v squared is equal to u squared plus 2as. We want the final velocity, v, u is 5.64, the final velocity is 0, and a is the acceleration that we just calculated, minus 2.089. So we're going to have 0 squared, which is 0, 5.64 squared plus 2 times minus 2.089 times s, Rearranging that, we're going to have the S is 5.64 squared divided by 2 times 2.089. Don't use an answer that's been rounded off here, just use the answer function on your calculator, and that will give you 7.611 meters. So the total distance will be the first part from B, which is 3.384, plus the 7.611 what we just calculated, which will give you 10.995 meters. And to freeze the figures, that will be 11.0 meters. Now I made this app, and the link for the app I will put in the note of the video. So here we can see the box down here. We can see all these being set at the right thing. You can try different parameters if you like with the app. And if you press start, you can see what's going to happen. Okay, so it's got to B, and then it's going to start to slow down and get to C. All the maths here is down on the right hand side as well. Okay, so this has been a video to show you how to calculate the distance between 2 points of a smooth rough slope. I hope you've understood, and I thank you very much for watching, and maybe you could consider subscribing to my channel. Also in the link of the video you'll find a link to my webpage where you'll find thousands of videos to help and support you with A-level maths. Thank you very much for watching.